Hello everyone and welcome to the Game Engine programming series where we write a game engine from scratch. In the last video we finished implementing the platform-independent Windows system that the engine will use to open a window and display the game. And we also implemented the platform-specific part for it for the Windows operating system. But of course we can implement opening windows for any platform that we want. At least that was the idea. And as you can see here, we can open Windows and it works just fine. And we chose to support multiple windows because we want to also use these windows in the level editor. And today we are going to write code to start hosting these windows in our level editor, which is a WPF .NET Core application. So in the intro of this video, I told you that these windows work just fine, and I lied a bit. That's not entirely true. And I found out about this because one of you guys told me, so thank you so much for that. And we are going to look at what's going wrong before we start the hosting code for these windows. So if you look at the function that we call to create this window, here we set up this client rectangle area and this Windows information that we use to save all the data about the window that we are going to create. And one of the fields in that structure is a style. And the default value for this style is Windows visible. So we are going to adjust the window rectangle to account for the style of our window so that we have this client area that we desire to have. So far so good, but after we adjust this window, I'm setting the style again here. So I'm changing the style after we adjusted the window rectangle, which is of course stupid from my part. So what we have to do is just to move this up before we adjust the rectangle, and it will be fine. So to show you the difference, I'm going to run it like it is now and take a screenshot. Let's go here and then I'll paste it here. Let's close this. Now for the fix, we just move this up again. Now I'll take another screenshot. Let's zoom in a bit and then I can show you what the difference is. So this one is the latest one after our fix. And when I switch between the two images, you can see that the size of the windows indeed changes. And we can even measure if that's the right size. So I know that I set the height of the first window to 800 pixels, as you can see here in our test program. The height of the first window is 800 pixels. We can go ahead and measure if that's true. So this line is at 105 pixels, and this line is at 1305 pixels. So if we would subtract 105 pixels from 1305 pixels, we would end up with 1200 pixels. So that's much more than the 800 that we asked for. But that's because I set the DPI of this monitor to 150% to zoom in a bit because I'm recording on a 4K screen and the letters are too small for people to read if I use 100% DPI. So if you would divide this by 1.5, then we'll end up with 800 pixels that we asked for. So that's right. Whereas the other one is just shorter, as you can see, and that wasn't correct. And now it is. So again, thanks. And while we are here, I'm going to do a bit more improvement in the code. One small thing that I can do here is just to use a reference. In get window size, we don't have to copy this rectangle to another temporary and then use that, which might be optimized anyway by the compiler, but I think it's better to do it like so, to be clear. And the other thing is also a mistake in set window full screen. The point of this style in this info is to hold the style of the window. So it's basically a constant field in this structure. And what I'm doing here is to override that data. And that's, of course, not a good idea. I'm going to remove that and just use the value of 0 here directly. So when we go to full screen, we use a null style, or in other words, a window without any style. And when we come back from full screen to a normal window, I'm going to use the style that we already had. So I don't have to construct it here again, which also might not be the same as the style that we already have. So I'm going to remove this. And that makes the code shorter as well. And that kind of concludes the fixes that I wanted to do before we start hosting the windows in our WPF application. So let me close all of these files except this one, because I'm going to need to change this one later probably. In the last video, we also saw how we are going to construct a main window for our game. And that's by using this structure, a render surface, because our windows are paired with a graphics surface from our graphics renderer that we will eventually implement here. So the main window is a render surface, and when the game starts, we will have one of those. And when we would like to open a window in our level editor, we also want to have one of these render surfaces. So to open and close these render surfaces, we need to write a function in the DLL that we have. That will let us open or create a render surface and destroy or remove one of those render surfaces. So the first thing that I need is an array of surfaces. I haven't included the graphics or anything about the Windows headers here in this file, so let's do that first. So remember that we have this platform, which is just the create function and remove function for Windows, and platform types defines this information about how we want to create our windows. And because we have that information here and we needed to set the parent for the windows that we host in the level editor, we also need to include this platform types header. Now we have an array of these surfaces, and then we can write functions to add new render surfaces and remove them from the array. Here we fill in the information for window initialization. Right now we don't have a callback, so that one is a null pointer. The parent is the parent window that we use to host this window. And we don't have a caption, obviously, because our windows that we host are borderless and they don't have a title bar. And the left top position is 0, and we use the initial width and height that we get from the caller of this function. Here we create a window, and for the surface we of course don't have anything yet, so this is just an empty placeholder for now, until we have the implementation for our graphics renderer. After creating the surface, we check if the Windows part of it is valid, and then we add it to the list of surfaces and return the index of the surface that we just added as an ID for the level editor. And when the level editor wants to close one of these surfaces, it calls remove render surface with that ID to close it. So that's pretty simple. And as we will see later, we also need to be able to get the handle to the windows that we create. So we need another function that will get the window handle for us. And of course, we need to import these functions in the level editor, in the DLL wrappers. So let's do that here. So here I added 3 import functions: create render surface, remove render surface, and get window handle. And those correspond to the functions that we just wrote here. And now if everything works correctly, we are able to call these functions to create a render surface for us. Next, I'm going to write a class that's called a render surface host. And that's an HwndHost. And the way we can... Oh, by the way, I was discussing something with one of my viewers here in Discord, which is always fun for me to do. So if you like to ask questions or discuss the design of the game engine with me, then be welcome to join the Discord server, and I'm always happy to interact with my viewers. Let's close this, and I wanted to look up something about hosting Win32 controls in .NET Core applications. Fortunately, there is good documentation about how to do this and the steps and even example programs on how to do this. So I'm going to put the link to this documentation in the description of the video, so feel free to check it out. And the thing that I'm going to do is just exactly what is stated here. So I don't have to show it to you. You can just read it in your own time if you like to know more, but it's exactly the same as described here, and it's pretty simple. So the first thing I'm going to do is to add in utilities a new class. I'm having doubts about if it really fits in the category of utilities, because we are going to call these engine functions, but I don't really have any other place to put it right now, so I'm going to put it in utilities. We can always change the place later on. So I'll add a new folder. And here I'll add a new class. So this render surface host will act as a framework element that we can use in our WPF application. And the way to do that is to inherit from HwndHost. As you can see here, HwndHost is an abstract class, so you can't instantiate it directly, and it inherits from framework elements, so we can use it in the UI. So this was an abstract class, and it has 2 functions that we need to implement here. And these 2 methods are called whenever the window is created and whenever the window is closed. So here we will create an instance of the window that we want to host, and here we destroy it when the hosting window is closed. In order to create a window, we need to know the width and height of the window that we are going to create, and we also need a property to store its ID that this function will return when we create that window. I'm going to have a couple of private fields. And we need a read-only property that will contain this surface ID. And then when we create an instance of this class, we can give it the width and a height that we want. Here we create this render surface by giving it this handle and width and height, and it will return a surface ID. And here we check if this ID is valid. And as you can see here, this function needs to return a handle reference. And that's the handle from our window that we just created. So we also need another field to store that handle. Here we get the handle to the window that we created, and we check if that's not a null pointer. Then we create an instance of handle reference. And when the window is closed, we need to destroy it, and then this method will be called. Okay, that's all we have to do for now. And to display this window in our user interface, we need another user control. So I'm going to add that here. And this one is the simplest user interface that we will ever create. It's just completely empty like this. And the work that has to be done is all in the code behind. Here, when this user control is loaded, then we will create an instance of this render surface host and then add it to this control, and then it will be displayed. So here we'll have a field that's an instance of a render surface host. That's all. Here, when this user control is loaded, this method is called, and we do it like this and not directly in the constructor, because when the constructor is not done yet, we might not have an actual width and actual height, because the user control might not already be placed in the visual tree. And that means that we don't have an actual width or height yet. And this loaded event is triggered when the user control is really being displayed. And that way we know that all the data that we need have been initialized. So here, because we just want to do this once, we again remove this handler from the loaded event. And then we create an instance of our render surface host with the width and the height that we want. And that's the dimensions of this control, wherever we decide to place it. And then we assign the content of this user control and set it to display this host. Of course, when we close our window, this host needs to be destroyed because that's hosting an unmanaged window. And therefore, we are going to implement iDisposable. Unfortunately, Visual Studio just has a code snippet or a quick action for this to implement iDisposable. So here it added a new private field for us. I'm going to change the notation to conform our conventions. And I'm going to put it within this region so it doesn't get in our way. And all we have to do now is here, when we are disposing, just to dispose the host. Remember that render surface is inheriting from HwndHost, which in turn implements this iDisposable. So we can call it to dispose any unmanaged resources that it has. And we can remove all these comments. And we end up with something like this, and we can collapse this region, and we don't have to look at it again. Next, we are going to add one of these views to the world editor so that we can check out if it works. Here, this blue area is where the renderer is intended to be. So let's remove these test controls from that area. So long, my beautiful vector controls. And now I'm going to add, in place of this border, just a render surface view. I forgot to remove the namespace, that's render surface, from everything. I just want it to be in the utilities namespace. Let's remove this. And as you can see, it already created a window for us here with the color that we have. Remember that our windows have this color, and you can see that our world editor now contains such window. Now we have hosted a native Win32 window in our .NET application. And when we have our renderer, the graphics will be displayed here in this blue area. And here is where I would like to stop for now. So today we did a couple of fixes and improvements for the window platform code, and we also managed to host the Win32 window in a .NET Core application, which is our level editor. Next time, we are going to look at what we should do when a hosted window is resized. Thanks for watching. If you like this video, please feel free to like and subscribe. If you join me on Patreon, you'll get access to the code on GitHub, so you don't have to type everything over from the video. Plus, there are also other nice goodies and rewards exclusive to my Patreon supporters. Please use the link in the video description to check them out. I hope to see you next time. Until then, take care and happy game engineering!